only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4, 3, 2, 1.
We've been dreaming about artificial intelligence for a long time. Very rarely, at least in our stories, was the dream not a nightmare.
It's alive! It's alive! It's alive! It's alive! It's alive!
Come and get it.
I think you know what the problem is just as well as I do.
I may be synthetic, but I'm not stupid.
I feel alive!
Skynet begins to learn at a geometric rate. It becomes self-aware at 2:14 a.m. Eastern Time, August 29th.
I'm an android, Lieutenant Commander Data. I've seen things you people wouldn't believe.
I want to talk to you about the greatest scientific event in the history of man.
Are you building an AI?
Apparently, it was not as big a surprise as we had hoped for.
Hello, I'm here.
I'm Patrick Coleman, and this is Into the Impossible, a podcast of stories, ideas, and speculations from the Arthur C. Clarke Center for Human Imagination at UC San Diego. On this show, we strive to live by Sir Arthur's inspired advice that the only way of discovering the limits of the possible is to venture a little way past them into the impossible. And today's focus is artificial imagination. In the past year or two, the artificial intelligence dream has come closer to AI reality. We're already interacting with artificial intelligence in our web searches and autocorrects and image recognition apps. Seemingly reasonable people are talking in practical terms about the massive job losses in the midterm future as more job functions are taken over by AI. And not only that, but some of those same reasonable people are suggesting that AI will not just surpass our intelligence in the next 10 to 30 years, but that this trajectory represents a major existential threat to humanity.
AI is a fundamental risk to the existence of human civilization.
In fact, this podcast comes out only a few days after August 29th, 2017, the fictional 20-year anniversary of when Skynet from the Terminator films becomes self-aware. But this isn't the only narrative of how artificial intelligence shapes human destiny.
Hurry, my will.
We'll talk about artists, generative AIs, neural nets, AlphaGo and Deep Blue, and what the technological enhancement of human imagination may ultimately look like. Sheldon Brown, director of the Clarke Center, and I spoke with Kenric McDowell, the director of Google's Artists and Machine Intelligence Group.
My name's Kenric McDowell. I lead the Artists and Machine Intelligence program at Google Research.
Kenric has the unique perspective of working with artists and technologists to harness machine learning's techniques in the service of art. And that point of view on artificial intelligence suggests a very different future. And it starts, for Kenric, not with a broader dream of AI, but with a particular dream, Google's Deep Dream, which is an image recognition neural network that, once it was trained on a massive number of images, was run in reverse, so that it dreams or hallucinates patterns and images in places you wouldn't expect. It's responsible for some of the most surreal, swirlingly colorful, and infamous images of the internet meme era.
My engagement with art and machine intelligence was largely a result of Deep Dream. My background as an artist is in photography. I've been a musician my entire life. I studied information and conceptual art at San Francisco State with Stephen Wilson in undergrad. And then when I started working for Google a few years ago, I came in as a UX engineer or a prototyper, so a design prototyper. So I came in working in real-time communication. My team very quickly moved over to work with Blaise Aguirre-Arcas in research and machine intelligence after he joined Google from Microsoft. And at that time, I started working on speculative design, prototyping for products that used AI, and just general theorizing of how AI could impact Google products. And then in 2015, in the summer when Deep Dream came out and went viral, Blaze was like, let's do an art show. And I was like, okay, well, let me help out here. I'm the only person in a 200-person org with an MFA. I'm extremely passionate about this intersection. I think it's also important to just make sure people understand, since they're listening and not seeing anything visual right now necessarily, that we're talking, I think we're using Deep Dream here as a shorthand for generative AI processes. So that's another element that is really interesting, that Deep Dream sort of opened up access to a whole bunch of other things because there was suddenly an interest in this. And now the idea of working with RNNs, recurrent neural net, LSTM, long short-term memories, to generate text or musical sequences, or to use T-stochastic neighbor embedding, TSNE dimension reduction, to visualize complex archives. Like these two things, hallucinatory techniques with neural nets like Deep Dream, those GANs, all those things kind of came out. Those things were being developed, but the creative interest was a lot triggered by Deep Dream. So it's a bit of a shorthand, but I think it's important to point out we're talking about almost an entire field at this point of techniques and processes.
And just for the people who have very little background, I mean, when you say a generative AI as opposed to another form, can you just kind of give like a basic definition of what that is and how that works?
Yeah, so Deep Dream and many of the hallucinatory techniques that are used to produce imagery are essentially reversals of the process of using a quantitative or analytical neural net. So something that would do object recognition in photographs, a neural net that could recognize, shoes or handbags or dog breeds or plants or animals or types of buildings or places, the way that works is you show an image to this system and it classifies it by looking for certain sets of features that belong to certain categories of objects. And those things are not coded in by hand. Those are learned through this process of training. The training data is labeled, but the images are fed en masse to the system, and it picks up patterns that we haven't prescribed. So that detection, that ability to perceive, can be run backwards, and it becomes an ability to generate imagery. And so it's called hallucination. And, there's an analogy there to the human brain producing imagery inside of itself and experiencing those images as any other image. It's a hallucination. It's something that is not there, but it's seen by the system. So that generative capability comes directly from the interpretive capability being reversed.
At the heart of how the original Deep Dream works is the idea of pareidolia, a fancy word for the very human phenomenon of the mind perceiving a pattern where there isn't one. Think hearing EVP ghost voices in radio static, or Paul is dead on reversed Beatles tracks, or the face of Jesus burnt into a piece of toast. Rorschach tests rely on a kind of pareidolia. So does mistakenly thinking you see a shark fin when you're just seeing a bit of random chop on the ocean while you're out for a swim. Our minds, hungry to find meaningful patterns in the world around us, are unsurprisingly good at making meaning when there is none. And that's perhaps an important aspect of imagination and our creative cognition, to see a possibility for something where one does not exist yet. What's exciting is that, in one sense, Deep Dream exhibits the same traits as this very human aspect of imagination, altering an image iteratively to exhibit more and more signs of the thing it thinks it detects in the original, until, as in one example, Van Gogh's Starry Night is transmuted into an unsettling, surreal sky filled with eyeballs and pufferfishish creatures and cars. This isn't too far off from Leonardo da Vinci's advice to artists, to stare at the stains and stones in their walls and to let their imaginations perceive the, quote, resemblance to various different landscapes adorned with mountains, rivers, rocks, trees, plains, wide valleys, and various groups of hills. You will also be able to see diverse combats and figures in quick movement and strange expressions of faces and outlandish costumes and an infinite number of things which you can then reduce into separate and well-conceived forms. A convolutional neural network run in reverse like Deep Dream seems to exhibit the same quote-unquote artistic ability to see things that aren't there, to go beyond the possible in the image placed in front of it into the impossible of what it might suggest. As Sheldon said,
when the Deep Dream stuff happened, it had these kind of two qualities, one of oddness, and the other of being able to get attention. So it got attention for this kind of emergent approach to, or re-emergence of artificial intelligence approaches with neural nets, gave it a very visible front end, and that visible front end was just odd. And so it seemed like, well, this must belong in art. It should have some, maybe it has a discourse that is relevant to art. And so it seemed like this opportunity that this group at Google coming together to try to then situate it more in a more interesting artistic context than just a kind of a superficial artistic context. What I don't think is part of the narrative is that at some point in Google, someone said, we should do something with art, but it kind of came about because this thing had artfulness kind of as a quality.
Another way of looking at it is that when you have something that is that odd, like you're saying, it has something to do with art. Art is kind of the only thing that could contain it, maybe. And I don't really know that that's even true necessarily. Art is a weird word. There's so many different meanings of the word art and so many different communities built around it and so many different intersections. So to say, like, can art contain Deep Dream or not is kind of a stupid question. But art, as it's generally understood, is able to absorb so many different things and is such a space of freedom. At least that's the narrative that we all share about it, I think, that is a place where Deep Dream could live. But it's also very contentious when it enters that place.
Yeah, that art could have a relationship with it. And as you said, that relationship would have as an element that contentiousness. Mm-hmm. So with any of these gestures too, when the Deep Dream stuff becomes engaged in an art discourse, there's then aspects of a kind of critique that come to it that otherwise it wouldn't engage that critique.
You might have noticed that the words to describe what Deep Dream does, dream and hallucinate, have a certain set of associations. In art terms, that might be the Dadaists and Surrealists of the early 20th century, like Salvador Dali, or the beat poets and Haight-Ashbury artists of the 1950s and 60s in New York and San Francisco. In fact, one project that Google AMI undertook was to send a poetry-generating AI on a cross-country road trip, a trip Kenric went on with artist Ross Goodwin and the Poetry Bot. Though who was Kerouac and who was Neil Cassidy and who was Allen Ginsberg is perhaps blissfully unclear.
So we did this road trip with Ross Goodwin where we were riding in his word car, and the car, it's a car with a camera on the back, a surveillance camera that is connected to a neural net that generates poetry based on the images that come into it, based on Foursquare API data, based on the GPS location and the time. And watching the documentary, it was really interesting because I had seen the poetry coming out on these receipt scrolls, and there was I think he ended up printing like 200,000 or 300,000 words, and reading them and kind of being like, okay, thinking about the system, thinking about how the thing made these decisions, looking for what made logical sense and what didn't. And then when I watched the documentary and the voiceover was reading the poem, I found myself actually listening to the words the same way I would listen to any narrated text and imagining the image that was described. And when I enabled myself to do that, when I allowed the text to be a text, it was pretty compelling, actually, and it was quite strange.
But those connections to past artistic moments or styles aren't inherent in what creative or generative AI can do.
There is an overlap in between people that are interested in especially generative AI and counterculture. So, it's tough to say what comes first. I mean, if you look at the origins of counterculture, obviously, and technology specifically, is something that emerges from the counterculture, specifically in the Bay Area and Silicon Valley, then, it's like John Perry Barlow, Stuart Brand, that whole cultural vector that took countercultural thinking and pushed it into the production of technology with an emancipatory ideology around it, and all that is very Silicon Valley. It is fitting.
And while being open to seeing the generated text or imagery as a product of the machine's imagination, independent of us, it is just as powerful to consider it as an augmentation to our own creative capacity.
One of the things that's, I think, interesting about it too is that when we think about like a generating tool of text or imagery or form or music, the way these neural net systems, the kind of model they give for what a tool can be, they have a memory, so you build this kind of this big memory system for them, and then they have ways in which they're making where they're kind of devising correlations within that corpus, and some of that we don't directly know what those relationships are. It's deriving them as you give it more and more stuff, and then you kind of interrogate it in a way to kind of produce or stimulate it or take it or look into it to kind of have it kind of produce, what it thinks those relationships are. If it has a certain seed, then what comes next? How does it interpolate between sparse information to kind of give it, to try to push it into a space of meaning? And those things then seem like they have an analogous relationship to aspects of creativity and imagination. Of course, I have to drop the I word here, and so I think that's one of the interesting things that you reflect on is what is that relevance of how these machinic systems are producing new phenomena to how we might produce new phenomena, and does it give us a valuable insight, or do we then kind of reframe our own creative processes because now we have this kind of external model that we can see produces a kind of effective result? So some of those kinds of questions, I think, are some of the interesting provocations that this work brings up.
To shake up how we think about this, let's step into another domain, the world of competitive board games. And one game in particular, the ancient Chinese game of Go. We're all probably familiar with IBM Deep Blue, the computer that beat Garry Kasparov at chess in 1996. Go is a Google more complex, with 10 to the power of 170 possible configurations. Beginning in late 2015, Google began putting its neural net-based Go-playing AI, named AlphaGo, in matches against professional players. It won its first match and went on to best world champion player Lee Sedol in March 2016. But the reaction of the defeated Go masters was very instructive.
So AlphaGo, as we know, beat the world champion at Go, but it did so in this very beautiful way, according to the top players. And actually now that they've had time to process the game and what happened, they've apparently found it incredibly inspiring, and it's opened up a lot of their playing, and they're playing in new, very new, radical ways, and everybody's trying new things, and everybody's rethinking how they play Go, and the top players. So it could have been an incredibly depressing moment for all of these people, but instead the fact that it gave them something really unexpected and beautiful and elegant, in their terminology, enabled them to go further. And so it is truly an augmentative loop that's happened there.
While generative AI hasn't hit that point yet, there's reason to think it's heading in that direction. Go is so complex that players develop an aesthetic intuition about the moves that will be successful. The same kinds of intuitive decisions that artists and creatives of all kinds rely upon.
I have an intuition that because I've been spending a lot of time looking at things that are generated by neural nets, and neural nets are highly multidimensional things. They can be up to 500,000 dimensions. They can be more than that. And when we experience them as art, we reduce them to 2 or 3 dimensions. So one thing I've really been thinking a lot about is that translation from highly multidimensional spaces into 2 or 3 dimensional spaces that we can experience in our imagination, in our physicality. And I've started to see that multidimensionality in other contexts that I didn't see it in before. And it's really changed how I have started to model my experiences. And it's happening purely on an intuitive level from interacting with like these projects like Rafik Anadol's project at the Salt Museum, which is an interactive installation in which you can move through millions of objects from the Salt Museum's archive in Istanbul, and you can sort of see how they cluster together. You can experience this massive amount of information in their interrelatedness as a spatial thing, but that's done by mapping it in a higher dimensional space and then flattening it down using this Tisney technique. And also looking at deep dream or any kind of hallucinated imagery from a neural net, you start to get a sense of these things existing in higher spaces where they're all connected, but you can never truly experience that space in a single zeitgeist. It has to be kind of experienced iteratively in these small pieces. And so the notion of moving through high-dimensional vectorial spaces, whether they be weather systems or cultural systems or geopolitical systems or semantic systems or artistic systems or emotional interrelated human, lives, there's a multidimensionality there that is becoming more visible to me just because I'm starting to think more about that on a day-to-day level.
Rafik Anadol, an artist born in Istanbul and currently based in Los Angeles, used machine learning to search and sort through the relationships between over 1.7 million objects in the SALT research collection, a massive multidimensional dataset of cultural artifacts. The immersive media installation he created, called Archive Dreaming, allows users to explore that collection in virtual reality.
And one of the most interesting parts about it is it actually fuses generation and research. So in addition to being able to peruse the museum archive space in this installation and in VR, and he's built some really interesting tools for kind of using VR as an access point for the documents in the library and collecting them and moving them and kind of gathering them and looking at them in VR. Mike Taika also built a component to the system that hallucinates new images that could exist in the multidimensional space of the archive embeddings. So, these documents that you see when this is run, they don't exist, but they fit the statistical profile of that archive. So in a way, you're looking at the archive through an unconscious imagination of what, unconscious is maybe a weird term, but like as an analogy to our own mental processes, this would be sort of the intuitive, dreamt, kind of freely associative, statistically probable thing, like in a dream, if you are combining 2 environments from your life, it's like statistically probable that those 2 environments would be, but they just not at the same time, right? So it's the same kind of thing where it comes from the source material, but it's new. So it's another way of experiencing the archive, which I don't believe anyone's done before.
As AlphaGo has turned into a tool for developing new strategies among master players, generative AIs can perhaps suggest other possibilities for aesthetics and intuition.
Yeah, I think intuition and aesthetics are ways of describing multidimensionality in the sense of, if we can make an analogy to our mental processes, like there are certain states of flow, there are certain states of creativity, there are certain states of intoxication that produce simultaneous access to like all of your brain at once, or what feels like all of your brain at once, right? And that defocalized view of the entirety of your consciousness versus a sort of like linear focused, like this, then this, then this. The types of leaps that can be made in that state are like, that's that kind of embodied, masterful state of flow. And my sense is that is happening in a higher dimensional space. And when we compress something down to something that can be like listed to ourselves mentally in language, we put it into a lower dimensional space. And that's, from a design perspective, for example, it's very hard to iterate a design from like point A, taking one step at a time, to some genius breakthrough product, right? Like the sort of like click wheel, the iPhone, like it doesn't seem like one could iterate in an analytical way to those things in that intuitive leap. Or obviously with a piece of art or music, it's even more extreme. But that intuitive leap seems to be happening in a multidimensional space where you're sort of shortcutting or short-circuiting around the need to flatten it into a linear thing and then put it out into the world. So that kind of decision-making, I think intuition is maybe another way of saying multidimensionality.
Well, and it's somewhat interesting with maybe some of the critique of the neural net methodology that maybe we could kind of try to bump up against some of that thinking. So when you are training a neural net to look at anything or understand anything, like say to help drive a car, you train it on 1 million instances of something, or train it to recognize a dog. You train it on 1 million images of a dog to try to get it to think, to be able to then pick a dog out of a picture. And you can look at that in one way and say, well, that's totally different than how the human brain works. Like, I don't have to drive 1 million miles before I know how to drive a car. I don't have to look at 1 million pictures before I can recognize something. And so I think with some of the deep dream imagery, some of the critique of it is that it's, because of the necessity of how it has to get trained in order to kind of produce effective outcomes, you end up training it on very kind of small subsets of imagery. It ends up kind of regurgitating aspects of that become kind of kitschy. But what it's maybe neglecting to understand in those critiques is that is how our own kind of neural processes. It may not take us 1 million miles to learn how to drive, but it's taking us, an order of experiences of moving through space that's equivalent. It's at least equivalent to driving 1 million miles. The way that we, on an ongoing way, create spatial cognition, or the way in which we create kind of like an image consciousness because of all the kind of imagery experiences that we're continually having, and that we integrate those within the mind, the plethora of these things. And simply right now, with the computational systems that we're building to do them, they're still at such a nascent phase that we're like still having to spoon feed every aspect of them. But even with that, we can still produce these kind of creative outcomes. We see things like Deep Dream, and it has this promise of what the world is, about to become. It seems kind of latent with, kind of futurity as an aspect of what it's showing us. And so I think that's another kind of interesting thing in that it does culturally. It presents a certain cultural experience at the moment, but it offers paths of the future that we might be going down.
I wish I could see beyond what I can see.
In that future, will AI be capable of having an imagination of its own? Or will it be a tool for our own imagination?
There's something about giving yourself access to treat the output the same way that you would another written output that opens up the experience. It just goes to show how maybe closed down it can be when you're sort of thinking about all this technology and stuff like that. First, so just thinking about these archives, that's what is maybe so compelling about it to me, was seeing it in this written form on this piece of paper. Suddenly I was like imagining it as like a real document and not just some generated output.
Yeah, but I find it interesting if it also can push you to think about your own process of pushing meaning and coherency onto phenomena. Mm-hmm. And so again, I think that's part of what comes up for me when around any of this AI work, that it comes out of certain relationships that are being made in what is literally a completely alien set of conditions, and we've kind of chosen to arrange it to produce a phenomena that seems to have an articulation that we can respond to, yet we are pushing it into being coherent in a way, to being kind of contingent relationships between objects and marks or words that we think have underlying meaning in the way that we would create meaning.
The tension between these two ways of looking at machine imagination is itself a spur to how we imagine our future in this alien landscape of artificial intelligence, and our tendency to fall into pareidolia, driven by our hunger to find meaning in the world around us. And while popular culture, and not a negligible contingent of the research and industry communities, sees that underlying meaning pointing to AI in the mode of Skynet, projects like AlphaGo and Kenric's work with artists and machine intelligence open up new possibilities for where this story may go. This has been Into the Impossible, a podcast of the Arthur C. Clarke Center for Human Imagination at UC San Diego. We'd like to thank Kenric McDowell for his time, and to point out that all the interstitial music in this episode was composed and, in many cases, performed by AI. We're also having a bit of a contest. Whoever can identify all the AI-related clips in the montage at the 30-second mark, and the one that isn't technically AI, email us at info@imagination.ucsd.edu, and we'll pick one person to win a Clarke Center prize. We would be remiss if we didn't thank our generous patrons and sponsors, including Viasat Inc., Sue and Steve Hart, members of the Founders Orbit and the James B. Axe Family Foundation. To find out more about the Clarke Center and our other exciting projects, research, and programs, as well as how to support our mission, please visit imagination.ucsd.edu. Audio production is by Wes Hawkins and Patrick Coleman, produced by Patrick Coleman and Sheldon Brown. And thanks to everyone who's been listening and sharing the podcast. We've got some great episodes coming up this season, including two Nobel laureates. Please leave a review if you enjoyed the show, share it with your friends. We appreciate it very much, and thanks again for listening.
The only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4, 3, 2,